So for our third problem, a rope is wrapped around a solid cylindrical drum. The drum has a fixed frictionless axle and the mass of the drum is 125 kilograms and it has a radius which is equal to 50 centimeters. The other end of the rope is tied to a block. So this is the block with mass equal to 10 kilograms. So what is the angular acceleration of the drum and what is the linear acceleration of the block? And we are also asked to find the tension in the rope, assuming that the rope does not slip. Okay, so for this problem, we will need to use both the linear and the rotational versions of Newton's second law of motion. So we have to recall the linear version of Newton's second law of motion. So we have summation of F equals ma. And then for the rotational version, we have torque is equal to I alpha. In order to derive the correct equations, we need to draw the free body diagram for each object. So for example, uh, the free body diagram for the block of wood. So if this is the block of wood, then there are two forces acting on the object or the block. So the first one is tension, and then the second one is the gravitational force, F sub g, which is equal to the mass of the block multiplied by the acceleration due to gravity. Now take note that for this case, the acceleration is downwards. So this is the direction of acceleration. And then for the drum, so suppose this is the drum, then this is the radius of the drum, and then this one is the force acting on the drum. The drum has a fixed axle, so we only need to consider the torques acting on it. Okay, now we have to take note that summation of forces along the y is equal to ma, and then we have here the summation of torque is equal to I alpha. Okay, so the forces acting, so we have this is equal to minus ma. So since the acceleration is pointing downwards or is directed downward. So this is our first equation. And then our second equation is we have the torque which is equal to R multiplied by the tension. So take note that the torque is tangent to the drum. Therefore, our equation for torque will be simplified to R times F. The only force acting on the drum that we will consider is the tension force due to the block. So this is equal to I alpha. Since the rope is wrapped around the drum, so ang rope class kay nakarap siya around the drum, we have this relationship. So the linear acceleration is equal to the radius of the drum multiplied by the angular acceleration. And recall also that for a solid cylinder, such that of a drum, the moment of inertia is equal to 1/2 mr squared. So this is for a solid cylinder. The moment of inertia is equal to 1/2 mr squared. Our first equation is this one. And our second equation is from here, we have RT is equal to, you have 1/2 mr squared multiplied by your alpha, which is in terms of the linear acceleration, this is equal to A, the linear acceleration divided by R. Or this is equal to R times T, or this is just equal to, yeah, R times T is equal to 1/2 mRA. So we can cancel further this R here. So we have we can actually get T, which is equal to 1/2 MA. So this is our second equation. Okay, And then from here, we can further simplify equation number 1. So equation number 1, we have T is equal to mg minus ma. Okay, so we have now two equations for tension. And then to eliminate A, we just substitute equation 2 to our equation 1. So we have, from our previous slide, we have T is equal to mg minus ma. And then this is our first equation. Our second equation is T is equal to 1 half ma. So what we will do is we substitute equation 2 to equation 1 so that we have 1 half ma is equal to mg minus ma. So we have 1 half ma plus ma is equal to mg, or we have 1 half m plus m, factoring a out. This is a, the linear acceleration, is equal to mg. We have a is equal to mg divided by 1 half m plus m. So again, this is the linear acceleration. So we have a is equal to the mass of the block, 10 kilograms multiplied by 9.8 meters per second squared divided by 1 half, times the mass of the drum is 125 kilograms plus the mass of the block, which is 10 kilograms. Okay, so this is equal to 1.353 meters per second squared. So we have now obtained the linear acceleration of the block. After this, we can get alpha. So the angular acceleration, we can solve it using this equation. So we have here alpha is equal to a divided by the radius. Okay, so this is equal to the linear acceleration divided by the radius. So the linear acceleration, we have obtained it to be equal to 1.353 meters per second squared. And then our r is given, which is equal to 50 centimeters, or this is equal to 0.5 meters. So therefore, our alpha, the angular acceleration, is equal to 2.706 radians per second squared. And lastly, we can get the tension. So the tension can be obtained using equation number 2. So tension is equal to 1 half times the mass of the drum, 125 kilograms, multiplied by the linear acceleration. So this is 1.353 meters per second squared. So the tension is equal to 84.56 newtons.